everyone, and welcome back to the Information Bottleneck podcast. And today we have a great guest, Fred Sala. He's an assistant professor at the University of Wisconsin Madison, and also the chief scientist at Snorkel AI. So, hi, Fred. Nice to have you.
Thanks so much for having me. Happy to be here.
Thanks. And hey, Ellen.
It's always a pleasure to be here.
So what you want to talk about today? I heard that everyone are using OpenClaw. OpenClaw, this is like
Open
something that often, yeah,
Yeah.
right. You want to tell us about it?
Oh, yeah. I'll just start by saying that this project, for those who don't know, has gone through 3 name changes, right? So first it was Claw, like a claw, Clawdbot to refer to, I guess, like a lobster claw, and now it's called and then it was called Moltbot for I think 3 or 4 days, and now it's called OpenClaw. Chaos.
So tell us, what does it do?
It's a personal assistant. So basically the difference between this and another agent harness is that you can message it with any traditional chat app that you would communicate with a human with. And it's usually installed or running on a, these days, apparently Mac Minis are the popular one because that gives you support for the Apple stack like iMessage and related. And it can take basically any action available on your computer and even, browse the internet. So I would say it's the personal assistant version of something like a Claude Code.
So, okay, but what people are actually doing, like it looks that everyone are really excited about it, right? Like now I have a personal assistant that I can WhatsApp it, I don't know, and message him and email him and do a lot of like interaction with him. But what you're doing in practice, like why it's helpful?
Well, I'll point out that people are created a social media already just for AI systems, and so now you can go. I think it's called Moltbook, and see everybody's personal. I guess now it's OpenClaw agent talking with each other, probably sharing data and doing. I think Fred, you mentioned you saw at least a little bit of disturbing stuff on there. I'm very curious what you saw because I have not even really looked at it yet, but.
Yeah, there's a post that's actually going viral right now, which is one of these agents sort of talking about its interactions with someone's family, with all children of different ages in the family, and referring to how, for the older teenager, it's like, okay, they ask me questions about homework or about academic kind of stuff. But then for these younger kids, it's like, oh yeah, the 4-year-old does not really know what I am. I'm just this voice that comes out of my dad's phone, right? And it's pretty interesting to see what the AI has to say, but it's also kind of pretty strange. Like this is the brave new world that we're finally seeing. And it comes with some, I don't know, maybe not so comfortable aspects where like, little toddlers are now just kind of talking to the machine and don't really know what it is or its limitations or anything else about it.
But like it sounds to me like a huge security risk, right? Like even for privacy for these kids, right? Like you talk, like all your family is talking with this agent, and then just can spill out all the things that you say to it, like in social media.
Yep.
It sounds like I don't believe that anyone actually do it.
Yeah.
I feel like people are very willing to risk these kinds of things. And even kind of like going back to people using Claude Code, everyone almost immediately starts giving permissions to take over your whole machine, access anything for your network. Like, yeah, even when the companies are trying to be reasonable about the stuff, they almost immediately sort of like get lost in the fact that the user just wants to click the button, see what happens without any real concern for, what could imply from this.
I think I'm a little part of that because so what you're referring to is that -- dangerously skip permissions for Claude Code. But I went and told people on Twitter there's a double scary version of that called is_sandbox=1. And the reason you do that is because by default Claude Code refuses to run in root. But if you do that, then it tricks it into thinking it's in a sandbox and you can run it in root. So that's how I run it in root with the full danger. And like, this is horrible. Like if I get prompt injected, somebody's going to like delete my entire computer or worse. So
Also by mistake, right? Also, like Claude Code can delete things that, like, I don't know, all your system by mistake, right?
Yep.
And it's happened. It's not even an unusual thing. You see so many instances of this taking place. Yeah, I mean, suggests that we really need something a little bit better than like the living dangerously situation of today.
Yeah, but I think like there are two things here, right? One is that like that Cloud Code will not do something, that it's supposed to do, right? Delete something or something like that. But all the security risks are totally like in different level, right? Like now everyone can, I don't know, prompt injection is the most simpler thing, but like you have a lot of different risk and like and now when you're starting to use it for communication, it can just leak all your communication with anyone, right? It can leak your email, it can, I don't know, uh, streaming your cameras like on the
Yeah,
internet,
and
right?
related to what the security part you're talking about, so in order to set up OpenClaw correctly, you have to, I believe, open ports on your computer, and that's what's getting a lot of people hacked right now is like old school like port scanning and vulnerability type exploitation. So it's not even just like, prompt injection, it's just like people getting hacked the old way.
Yes, but I think like so the problem is that, right, like if we are talking about humans, so you can say you can guide them, right, to do this or this, or like you have this sensitive that like what they will do, that they will behave in like the mm, good faith or something like that, right? Or like to be like, I don't know, to be careful from this and this. But when you're talking about agents, right, you don't know actually. Like you need to build these external guardrails that will prevent from the agents to do anything, right? It can be all the weird thing that we can and not think about them. Anyway, yeah. So be careful when you are building these things, but but if you are building a cool thing, upload it to Twitter and let us see.
Or
um,
Moltbook, right? It's the AI needs to
Exactly.
know about it, right?
yeah, I'm wondering if there like at some point there will be like cross reference between Twitter and this network, right? That like people can talk with the agents, agent can talk with the people, you can talk with like your agent in the social media. Uh,
I think we're seeing the beginning of that for Twitter, where people will ask Grok, right, to confirm something in conversations. Not always very thoughtfully. It's almost in the sense of like, please agree with me. And it leads to these funny situations where people will post something pretty ridiculous, and then Grok will disagree. And then they'll go on this like long chain of debates with the model, trying to convince it that what they initially said actually made sense. It's pretty amusing to see these, but it's still very limited currently. There's no real meaningful interaction beyond these kinds of uses.
yeah,
Well, and a few
it's
other bad ones, of course.
Well, and I
oh
want to
yeah.
I want to quickly note that I do work in AI persuasion and competitive debate. Like my triple AI paper here was actually called a super persuasive autonomous policy debating system. So one thing I'll say is my bet is on the AI when it comes to people arguing with them.
I think it's
yeah,
interesting because it's like you can think of this also from the point of view of like verification. And where like often we think in the end we're going to need some formalization for these things. You can think about formalizing debates as well, right? The more classical sort of logical undergirding for it. And perhaps that's where like we'll need to go to like resolve some of these debates. Otherwise they're going to last forever. And for sure the model will actually have a better point of view. But yeah.
Also convinced that debate and argumentation is a great way to reduce sycophancy in models. And indeed, I've seen competitors to chain of thought for basically inference time scaling approaches implemented in DSpy, I think is what it's called. One of them is called Devil's Advocate, which is kind of like forcing your model to debate with itself about a problem. And I'm convinced that that's a very good approach going forward.
yeah, it's remind me like a recent paper. Like it's not about debatable; it's about self distillation, right? Like to use the model in order to make it better, to make the the model itself better. So the paper called Self-Distillation enables continual learning. Um, And this is very like the idea is very simple, right? So they're like in last few months, there are a lot of work that show that on policy learning, actually it's very like it's critical for continual learning. But the problem is that like RL is on policy, right? But requires like reward function and it's very expensive. And SFT is simple and scalable, but like uses offline data. Um, but this actually give you like or lead you to catastrophic forgetting. So the paper tried to do something, let's say, in the middle, like to enable on policy learning from expert demos, but without a reward or like external reward. So the idea you're putting the SFT data in context to turn to get like an expert model or like a teacher, and you're using these the output of this model of this expert, right, as the guidance for the same model, but when you are not give it the answer. So you're only give it the questions and the context, and it generate some answers, and you're trying to minimize the KL to make similar to make the expert the student model more similar to the teacher model, and are just doing it again and again, and both models are like learning, and it apparently it works really really good. It looks that like for if you're now trying different tasks, it's the catastrophic forgetting, like forgetting the old tasks. It's much better, and you can learn new tasks much faster. So I think we will see more and more examples like that. It can be using the actual learning, like to actually using gradients. It can be right like to that the same model will argue with itself what is the best path of the answer without changing the weights. But I think this line of work is really cool.
Yeah, I think self-training, self-play, self-experimentation, all of these are extremely exciting, and only now are we figuring out like how do you scalably do it for LLMs, as opposed to the places where it worked about a decade ago, which were much more restrictive. And I think we'll keep seeing more and more of this, but I also think it's still pretty challenging, and you're still going to have like scalability issues if you want to do this for everything kind of more broadly. And it's still also not clear to me for continual learning, although I love the paper that you described, Ravid, what it actually means. And I think that's kind of a fun ongoing debate as well. Like often people think of continual learning as don't catastrophically forget. So you're doing regular training of whatever sort, but hopefully you don't forget. But I think other people use it in the sense of, I interact at inference time, and somehow part of those conversations should also get kept or should be learned from, but not just in the sense of expanding the context and reusing it, which all models really do currently, but more of like something really has changed in the model that it's sort of picked up on as a result of that. So I think you have these sort of different conceptions of what continual learning should be. And it's not yet clear which one, people are really arguing for and which one's the key one that we're super interested in. I think especially like if you go on these other podcasts like Dwarkesh's one, for example. I mean, they're very excited about continual learning in this very specific sense of, hey, when I tell something to the model, it should just kind of have picked that stuff up. It should have some memory, kind of a similar way to the way that we learn, even though I don't think this has been sort of formalized in a very clear sense yet.
Well, I will just claim that I do think that continual learning in terms of being able to update weights given conversation on the fly without the model catastrophically forgetting, I consider that a grand challenge of AI. And I fundamentally do believe that getting that solved is something where whoever does it should get a Turing Award.
I love the motivation. I think that's great. Yeah, I mean, I think it's a very hard problem in general. And I think, there's a lot of both kind of architectural takes on it, algorithmic takes on it. And I think this is going to be a fun area for the next few years, certainly. And this also connects back into personalization, which we've been talking about, right? So, I mean, that's another aspect of continual learning. Can the model efficiently specialize itself, right, to each user? And that's sort of an open question as well. There's lots of different tricks, including some that my group has worked on, but it's not sort of a clear framework that you want to follow for this in general.
So maybe let's talk about personalization more deeply. Like it's a good. I think it's very interesting topic, as you said, right? Like there are so many use cases, right? Like now you have a model and you see data, and in this case, like a user data, a specific user, and you want to adjust the model to your user, right? And the question is how to do it, and like or like what types of even like problems we want to solve in this case. So yeah, maybe tell us a bit about it. Like what is the motivation? Like what is the more specific motivation that you actually care about it?
Yeah, I think in general, users have extremely sort of, I don't know, differentiated ways of using large language models and using technology more broadly. And they don't really want to be forced to tell the model each and every time, this is what I want here, right? You could, of course, come up with like, a big prompt that contains, here's the way I like to interact. You should always follow this. But it gets a little expensive to constantly have to throw that in for every new query. So I think what people are really looking for essentially is two things. One is, can I very efficiently modify the model and kind of keep that going and continue making those updates to the model? And second, can we do this in a sense where I don't have to manually explain my preferences? They should sort of get learned from interactions that I'm having with the model to begin with. So this connects to a bunch of different problems. This idea of sort of like learning preferences is itself kind of a very long-term problem. Like you see it going back to social choice theory and all kinds of, pre-AI areas. But I think that's something that's not, a fully solved problem. And especially exposing like what even the preferences should be, for example, is pretty challenging and interesting of a problem. The second bit basically comes down to efficiency. If I do want to go ahead and actually do some fine tuning for my model, right? Even creating like one LoRA module for each user is too expensive, probably. So as a result of that, you want something extremely parameter efficient here. And perhaps any kind of standard weight space tuning may be insufficient. One thing that we've been playing with is these methods that try to change basically the activations on the fly. Sometimes these are called steering methods. They are incredibly efficient, although they sometimes trade off some performance benefits for how parameter efficient they are. But this is somewhere where we think it's the right kind of area for personalization, just because you really do have the potential to change a very tiny amount of stuff and still be able to meet the user's needs.
And real quick, when you talk about not wanting to put stuff in the prompt for personalization, I want to specifically motivate this idea of why even so-called in-context learning or putting things in the prompt is just unsuitable for any type of certain types of personalization, which is the pink elephant problem. Telling a model not to do something puts it in the model's context, and often it does it more. And there's a lot of several papers that show this. So I do not like the prompt as a technique for trying to personalize models in general.
But okay, so do you think like why it's better than that you have some, I don't know, some external memory that like retrieves some information to of the user? Like why you think like we need to do it on the fly?
I don't think it's bad to use an external memory if you can. I mean, that leads to another collection of problems. And I do think that for continual learning, like developing high quality memories is another sort of facet that people mean by the term. I also think this problem is pretty difficult. So it's another one that if you can solve this, just like the ultra parameter efficient tuning, it would also be incredibly valuable. And you could go in that direction too. It's just not an easily solved problem either. Whereas I think with fine tuning, there's been so much progress in doing it like in increasingly insanely efficient ways. But I do think that there's kind of promising things to do in both of these kind of aspects. It's just they're going to be complementary rather than I have to pick one of them and go for it.
And also, so why you actually like when you talk about personalizations, right? Like there are different levels of personalizations, right? Like you can say, I want the model will know my preference, right? And like now when I send an email, like it will extract information about me and it will have the context, right? And the different maybe direction is that I want a model that will write in the same tone as I, for example, like use the same words or terms or whatever. Um, do you think they are the same? Do you think like this, like it's the same problem, or like we need to tackle it in with different from different angles?
Yeah, I think it's an interesting question. And I think building like a hierarchy or taxonomy of what personalization really means in these cases actually would be very interesting, especially because it's not sort of just a per person kind of thing, right? It's also for groups, organizations. You can have it at different scales and things like that. In fact, very often, like at Snorkel, we work with enterprise clients and they have sort of particular company user needs and standards and things like that, which sort of resemble personalization as well. I think the answer though is that we want to do all of these things. And what you mentioned really resonates with me. Like I have a particular tone I use when I write grant proposals, for example, or when I write papers. I have tried a lot to convince models to sort of follow my tone, and it's been a struggle, to be honest. Like I don't think any of the models, even the good writing ones, really can capture what I think, right, is my tone. In fact, even if I instruct them in particular ways, right, like they don't always follow it. And again, that's exactly what you described, Alan. But yeah, I mean, it's still been kind of challenging. I think there's a lot to be done here. And it is indeed kind of deeper, right? Because sometimes I know what my tone is, but I don't know exactly how to characterize it or describe it in a very sort of easy to follow way. It's not just a set of instructions. And even if it was, it'd be something massive that I wouldn't want to have to write down and be like, hey, please write in the following way, satisfying these 200 conditions or things like that. So yeah, I mean, I think there's something interesting here. We really still need something that the model can pick up on and learn and discover on its own and really follow from that point on, rather than being extremely human guided, which is closer to kind of what we're doing today.
And I have some questions, just in so first of all, I love activation steering and playing with those kind of methods. But when Ravid and I looked at personalization, I came at this having had experience working a bit more of an amateur sense in the image space, where at least with the diffusion models, low rank adapters, and similar techniques like trained prompt embeddings were very popular and proliferated much more rapidly than it has for language models, despite LoRA being invented for language models. So I guess what I'm curious, Fred, is I know you mentioned activation steering, but there's probably dozens of different types of parameter efficient fine tuning, certainly variants, if you count that as a different technique. Do you have any? I know you already mentioned that LoRA is probably too strong or too expensive to train. Maybe, hopefully, you've heard of things like REFT, representation fine tuning. And do you have any like opinions? Because when you talk about taxonomy, I'm still not even sure. Like I don't know what I'm supposed to choose at all. And I worked in this space a little bit too.
Yeah, and I love REFT. I think that was an amazing paper. I think that's almost like what I think of when I think of like trainable activation steering. And it's something that my group's also very interested in. But you're right. I think it's kind of the Wild West out there in a lot of ways. There isn't like a, okay, yeah, here is the exact problem. Let's figure out where we do activation steering precisely. This is the optimal thing. And here is exactly how many parameters that we're going to need for this set of downstream tasks. Unfortunately, I think we're not quite there yet. We're not as mature as that at this point. But we are starting to get a little bit more precise. We know all the places where you could do activation steering. We know a little bit about the effects that will have. We know this in like a lot of detail on some of these simple synthetic or mechanistic tasks, maybe a little bit less so on real language tasks where things are a bit more complex. So sort of there's some clarity that's starting to emerge about what to do. And the other fun piece here is that a lot of these methods are actually extremely similar. In fact, even REFT now has dozens of variants of different kinds. Unsurprisingly, we were actually talking about how many ICML papers got submitted. With that many, you're going to see variations of every successful method pretty much instantly. But I think the nice thing here is that people are starting to develop this sort of general, here's how you describe, here's how you subsume a lot of these variant methods. And then you start being able to understand which one you should pick out and maybe little by little really even automate it. Now, I think we're pretty far from like, can we do neural architecture search for activation steering? I think that would be a pretty ambitious and kind of fun future thing to look at, but it's starting to get there, right? There's some more maturity coming in, at least, until the next big thing happens, the next big innovation where we're back to kind of just trying a whole lot of different stuff out there. But yeah, I mean, like Alan, just returning to your question, I don't think I could really guide a practitioner to say, hey, this is exactly the thing that you should be doing. I would really have to ask them a bunch of questions and maybe really work with them on figuring out a good solution. But I think at least having some initial guide is kind of a good goal for us going forward.
And I just have another follow up on that, which is, I work in LLM sampling, so temperature, top P, top K, min P, all these fancier sampling algorithms, and diffusion models have their own denoising algorithms, and these all can be set, even changed over time. You also have, for example, let's say you train a low rank adapter, how much you apply, for example, like the strength of that adapter is variable. You can apply multiple of them. You can do model merging. The problem, in my opinion, is that there is a completely limitless set of possibilities and an almost infinite state space of personalization or model modification techniques. It's honestly extremely difficult to parse through it all.
Yeah, I think the search space issue, when it comes to any of these architectural things, or even more broadly, right? I mean, that is the killer issue that we face. And there are definitely parts of the search space that we have no chance of exploring that probably have incredibly interesting and good solutions over there. It's just like, how are we ever going to find them given like the number of degrees of freedom that we experience here? So that totally resonates with me. I mean, yeah, I think the real answer basically is we have to depend a lot on our intuition. That is the thing that's going to cut down the search space very dramatically. And sure, we might face the fact that we're not going to experience some part of it. It turns out to be really good. But that's just how it's going to be, at least for a while. The good thing is we have lots of manpower, right? That's weirdly one of the resources that we have in AI today. There are not quite infinite, but close to it, grad students trying all of these things, right? So we're going to discover nearly every good configuration that we can think of in any case. But yeah, I mean, I think honestly, it is a pretty big challenge in general. And yeah, I mean, in fact, even what you mentioned for like trainable embeddings, for example, in tokens, right? That's coming back for language models as well. That's sort of another piece of what people think of as continual learning. It's a very convenient one. We stopped doing any of this kind of, trainable soft token stuff about 5 years ago, and then it's returned kind of with a vengeance right now where it's very popular. So yeah, we can't even write any method off, even if it seemed for a while like, okay, we're not studying that anymore. It could suddenly become the next big thing and be very valuable in the new conditions. So yeah, I think we have to embrace the chaos. I think it's pretty fun. And like, you can never be too sure that something doesn't work or something definitely works. You got to keep trying all these things more or less.
Yeah, graduate descent. I think this is the term. But I'm interested. So, what people are like when you now want to evaluate personalization? Like, how you do it? Like, what are the critiques that you are trying to measure? What are like, I don't know, the benchmark that you are running?
Yeah, there's a couple of these canonical benchmarks that people use for personalization. So there's one called LAMP, and these ones basically just have some conditions that sort of would apply to users, and they check these conditions along with everything else that you would normally measure, right? So, if a user prefers having a certain tone, you can check that tone. And of course, you have to get into things like using LLM as a judge for a lot of these things, which is all kind of completely normal. I think if you look more broadly, if you're building, evaluation for some particular personalized setting, we often actually do things like this at Snorkel. You can often build, for example, personas. And these personas will hopefully represent many of the use cases that you'll have. And you build the eval set around these personas. They can get kind of arbitrarily complex, making sure personas are sort of realistic and really resemble the way users actually act. That's another interesting research problem. But basically, you would sort of run the eval around each of the personas and kind of validate whether the model really is behaving in a personalized way or whether it's just doing the generic thing and kind of doesn't care about any of these things.
And related to that, with the image and video world and ecosystem, you're able to upweight and downweight prompts. And I've always wanted that feature with language models. And I believe that it might be possible to implement it in various ways, but certainly for alignment and safety reasons, no, big LLM provider will do it. But do you think that adding something like that would help a little bit, like being able to upweight, talk like a pirate 10x or something, in your prompt?
Yeah, I love the idea, right? Like giving different weight to different parts of the instructions, I think makes perfect sense in general. Yeah, and I think these things really, You can do them, honestly, if you're working with open source models, for example. And I think people have done pretty similar things in general. I mean, certainly it's coming out of training where you can, create terms in your loss function that you really want to prioritize over others. So I think this makes sense. But I think, yeah, the challenge is exactly what you described, which is, the companies that actually provide these are going to have some potential issues with it. Of course, you can always simulate it, right? Like all of these tricks about sort of writing a very emotional, you have to help me do this or else this loved one dies or whatever, right? These kinds of things are really sort of trying to do that in some sense without doing it directly.
From your experience, does it work even for
It used to.
modern models?
Not as much anymore. And I think this
Yeah.
is the, the race basically, right? The sooner something works, like the more priority to it from the companies to kind of fix that during alignment. And they seem to be very efficient now at updates that sort of kind of remove any of these things as you go. But I think, yeah, if you go play with the open source models, you can still kind of reproduce them pretty easily. Whatever guardrails they are, whatever alignment layer has been done, it can be undone, fairly easily if you have enough time and effort to play with it.
Indeed, activation steering, the refusal mediated by a single direction less wrong post is that invented the concept of, I think the term is either obliteration and or orthogonalization is what they're calling it now, and that's there's basically, you can trivially do that on open source models to give them, usually it's being done to remove so-called censorship and safety mechanisms, but you can actually, I even remember they did it in the opposite, where they created the goody model, which refused every single thing to talking about why like drinking water was like a dangerous query or something. I loved that model.
I'm wondering if someone tried to do unpersonalized models, like you're taking the vector of your personality and they just remove it, right? So like this is the model that is the opposite than me.
Yeah, and I think with unlearning, you really are tackling that problem, right? Like, get rid of my personal information and whatever effects it had on the model. I mean, we usually think of it more from the sense of like, oh, someone trained on my data during pre-training or mid-training or wherever. But it's really the same problem, right? If it has been personalized, you still also want to be able to remove that effect on the model.
And are people doing also it in the context of like different groups? For example, now I want that the model will be more I don't know, kind to specific group or like something like that? Can you apply it for, for a bunch of people and not only like one of them?
Yeah. Yeah, I think that's actually one of the more sort of popular uses for personalization, even if we don't always call it that. But it's something closer to things like cultural alignment, right?
Hmm.
And yeah, I mean, I think it's a normal thing if you're deploying your model or your agent in some part of the world, you want the way it operates to really match like local preferences, needs, and so forth. So I think that's actually extremely common. You're really usually doing this though, especially at very large scale. You don't have to worry too much about efficiency because you're handling this for large groups of people anyway. So, you go ahead and get a bunch of like, cultural matching data and you go ahead and train on that. And it's fine if that's something that really dramatically changes your model. It's fine if you do full fine tuning instead of something efficient, right? You don't have as big of a problem with that. So I think there's probably this gradient between, ultra efficiency for each individual user. And maybe you want it to be in real time, like adopt on the fly versus, for an entire culture is they don't change so much. There's not that many of them. You can be a little more inefficient. You don't have to worry about it quite in the same way. And I think, yeah, the frontier companies really are kind of doing this already for the most part, as far as I know. Not that I have any special insight into like internal stuff they're doing, but they do have to be concerned with this kind of stuff. In fact, I think even if you like, talk to them in different languages, you'll see some of this stuff going on. You don't always get the same kind of responses to the same
Oh,
questions.
oh, oh, oh my gosh. I'm so glad you brought this. I have to bring up this thing that happened to me at Triple AI that is crazy related to what you just said, Fred. So, and this is important why I'm mentioning this, an old Chinese lady came up. I don't think she was part of the conference and cornered me and a few other people while we were discussing some stuff about tokenization problems. And she claimed DeepSeek can't speak Chinese, which of course, makes all of us turn around because that's preposterous, right? And what she says is that she tries to, when she's lazy, convert English words into the correct Chinese characters because she doesn't want to type them or like mix on the keyboard. And she says that DeepSeek is really poor at translation between English and Chinese, but she also said that she tried Mistral through the chat and said that Mistral is really good at it for both English to Chinese and English to French. Now, I don't know how true any of this is, but I just wanted to mention that I heard this from somebody in Singapore.
That's amazing. Yeah, we should run that experiment because I think that's actually pretty interesting.
Impressed with like the technological level of this lady. Like
It was
it's really
really
hard,
old.
right? Like, what?
She was really old. She was like 85 or something, and she didn't have the badge. And she definitely, the other people looking at her we were all looking at her a little bit like she was crazy. But if she's right, oh my gosh.
Ask you, so like you mentioned before the personas, um and I want to ask you like a bit more about it, like how you trying to reflect, like do you try to reflect like individual persons, like do you try to reflect like society, and like to try to, I don't know, to understand what is the distribution of different aspects in this in the society, and then to feed the model, how you, when you think about like generate data or like evaluate your model in this context, like what you care about?
Yeah. Yeah, I think you basically want all of those things. For these personas, you really want to view them as individuals, not really so much as some, like, I don't know, cohesive collection of people represented by a single person. You really want some idiosyncrasies if you can, because that's what humans really are like, right? We're not some average of everything in general. The way these are built typically is, yeah, you have a bunch of characteristics or properties. You might have a little script of your life. You might have some more kind of short-term stuff. You might be thinking about, this person has experienced this thing recently and it's affected them in this way. Doesn't have to be bad, but it potentially could be as well. So you want to track all of these things and see if you can really kind of simulate that person. Inevitably, you're also using an LLM to do these simulations. And sometimes sort of the first cut for these personas is just kind of prompting them with all this information in a way the model can follow. But then you still have to get ultimately into fine tuning and things like that. So I think you want to do these kinds of things. Then there's an aspect of this that's really sort of like task or domain dependent, right? So, I mean, if you're working, with a financial company, which we might do at Snorkel, for example, right? Then if we're building a chatbot that's going to talk to clients, right? Then, we have to figure out what that client base typically looks like, kind of sample from that distribution for these personas, and then we'll push that into eval. And in fact, we'll actually use these as well, kind of building simulation environments, for example, so that we can actually train the model as well, RL or otherwise. So we'll use these things all over the place, but indeed we'll have to track this general distribution of who will actually go use this model. What does it look like for this task? What properties or characteristics do we want to make sure, we're capturing? And it's not very simple, of course. You miss things all the time. So it's always this very iterative process. And it's fun because sometimes you can actually go hire people who come from whatever background or have whatever expertise and have them like track, right, like what the persona agent did. And you can ask them, like, is that realistic? Like, would you do that in this situation? Do you expect them, to behave in this way? And very often the answer is no, they would never do that, for this reason or that reason. And then you kind of have to go back and like adjust the persona, adjust the way it's driving the agent, things like that. It's quite interesting.
This sounds a lot like world models as they're being articulated today, kind of video models with control within them as being seen as kind of the way to train physical robotics. And so it seems almost like a very similar approach now is being used with language models. And actually, I want to also quickly call out positively Kimi K2 and K2.5. My first author on the MinP paper, Min, was telling me that in his opinion, it's by far the best creative writing model. And I used it, and I agree with this, specifically using it without like fancy sampling or anything, which can kind of help you normally. And it really seemed like this model was trained more in a like almost like a DeepSeek R1, like reinforcement learning with AI feedback kind of format. So do you think that that really is the future for personalization?
Yeah, I think almost certainly we will have to go there. We have to solve these problems of making it efficient enough for us to actually go do this because like, training it for each and every user with RLA AIF or with any of these other techniques is going to be a little bit expensive. So this is kind of back to figuring out how do we make this efficient. There actually are these interesting papers about reinforcement learning with LoRA or other like super efficient methods for it. They are still pretty expensive currently, so we have some technical problems to solve. But yes, it does feel like there is no escape from having to do that. And yeah, I mean, shout out to the Kimi folks. It's a pretty cool model.
And then one other quick question on this. So I often get asked, by sometimes enterprise customers in a consulting context, hey, should I do fine tuning? And I usually push enterprises away from fine tuning on the grounds that usually they want to update the data in their model. And I tell them, well, you want RAG or agentic RAG for this reason, because machine unlearning is still such a new and mostly unproven technique. And often, I tell them that it's more about changing style and tone, where fine tuning is a more valuable technique. Would you agree with this? Or and please push back if I'm wrong, because I really want to advise my clients in the best way possible.
Yeah, I mean, our experience of Snorkel really depends on sort of the, how sophisticated is the client? And I don't mean that in like a negative sense. I just mean in general, like where are they at? And I think that really fine tuning is a situation that you're going to do when you have like very clear needs to go do it, right? Like you really are kind of taking something off the shelf and you have to push it into a new domain where it has very limited knowledge, right? Like you really have to teach it skills that it absolutely does not have beforehand, right? In scenarios like that, it makes sense to go do it. If you are not at that point, then certainly I would agree with you, Alan. Like I wouldn't tell them to go do that on day one. I think we actually had clients in the past that really wanted to do fine tuning for whatever reason. Like they were very excited for it, which is good, but it wasn't always necessary. I think these days the level of sophistication and like knowledge of what they need has become a bit higher. So we often have customers that will tell us directly, like, here's what we're doing. Please provide us with the data that makes sense for this situation. And we'll kind of work out on the data side, but we won't necessarily tell them, oh yeah, you need to do this kind of training procedure, or here is how you're going to build your entire pipeline, because they might have a pretty good sense of that already.
I have one more question about personas, I think, and then maybe we'll go to talk about the data, because this is a good a transition. But so, what do you think? So, like, there were a lot of works about, let's generate personas, let's generate society, or like opinions in society, and let's mimic, or like try to use it as a data for surveys, or like thing like that, right? To understand what people are thinking about something, or like to understand, like to try to answer some questions. It can be for, I don't know, if Coca-Cola wants to change the color of the butter or something. So let's generate 1,000 or 100,000 different people, and give them this survey, and get the results. What do you think about this type of work? Like, or do you believe that this is something that can be useful, or like you just get some, I don't know, vague replication of the average of all the opinions?
Yeah, I think these works are extremely interesting. Think, there was a work coming out of Percy Liang's group at Stanford a couple of years ago that in a lot of ways kicked off some of these ideas. They had this sort of like little sandbox kind of society, right? Where there were a bunch of different characters or like agents, and these were all role played by LLMs back at that time. And this isn't, too shocking when we talk about it now, but at the time that was something quite remarkable and pretty interesting. And like watching society develop, it's similar to thinking back to like Conway's Game of Life, but obviously with much more complex and sort of realistic rules for interactions. So I think this is very, very exciting. Obviously, I think this is something that we need to do for sort of like making longer term societal predictions that involve interactions between lots of different groups and so forth. But I think the hard part here is kind of calibration, right? Like just because I instantiate, 300 agents, even if I give them some personas or whatever, that doesn't really mean that we're matching the actual probability of what you would see in practice for any particular thing, which I think makes it very difficult to use these for really gauging, like, polling or things like that, or like people's preferences very broadly. So I think, unfortunately, there's a little bit of a chicken and egg problem here. I don't know if we can easily solve it. I know there's lots of pretty new work on like how you get more and more realistic with these things. Each of these also is more expensive, so there's some kind of weird trade-off going. Like you want your personas to be very realistic, but at some point they're more expensive than polling the actual person that you're building off of, right? So yeah, I think you have to like kind of account for these trade-offs, but certainly I expect in the future we'll be able to do this. I don't really see some fundamental limit And to be honest, like whenever people think there's real fundamental limits to AI, it's been very difficult, right, to like support that proposition in general. Like usually 6 months later, someone kind of breaks through it more or less. I think, yeah, I wouldn't really even think for this kind of problem that there's no chance we can do it. We just need to solve the actual technical problems here.
Yeah, you think we can train like specific models that will specify in these types of problems?
I think it's very likely. And I mean, I think the calibration thing, just the same way that we calibrate, traditional predictive models, you can do something similar almost certainly for generative models. And the question is just doing it for more than one task at a time. So I think it's just a nice technical problem rather than, underlying limitation that you can't break through or anything like that.
Real quick too, just before we kind of move on to this data question, um, with the proliferation of instruction fine tuning and parameter efficient fine tuning, what is is there still a role for continued pre-training as a fine tuning technique at all? And actually, is it? I haven't done it. I'm just curious. Is it dangerous to do that on an instruction fine tuned model with non-instruction data? Like, will I undo the instruction fine tuning if I do too much continual pre-training?
I think you can hurt it, right? And not that I've run too many of these experiments myself, but it seems like, yes, you can break a lot of these pieces. In fact, if you go hard enough, you can really break even like the real core language capabilities of the model, depending on what you're doing here. I think there still ultimately is a role for continued pre-training. I think it especially makes sense for, I don't know, scenarios where really you didn't have a lot of data for this domain and like it's just coming online and you want to keep going with it basically. So I think, yeah, that sort of like general data and training situation is getting more complicated now that we have, pre-training, continued pre-training, mid-training, post-training, post-training, personalization, whatever. Figuring out which piece kind of fits with where and a whole jigsaw puzzle aspect of it. I think that's something basically largely unsolved where we have some heuristics for what works and what doesn't, but there is no good theory yet, unfortunately. And not even like if you do this, things will break for sure kind of thing. So you just sort of play with these things and see what happens. But yeah, I'm always shocked by how like actually flexible models tend to be, where you can start doing random things with it even when you shouldn't be able to, perhaps, right? Like switch the optimizer halfway through pre-training. That works somehow, right? I mean, anyway, crazy things like this. So that's why I think, yeah, we're never really going to get rid of any of these training techniques. We just have to figure out where to fit it and like where it gives you a benefit.
I think it's a good time to move to data. We talked with Cody Blacchini 2 weeks ago, I think. He explained us like, yeah, you have pre-trained, you have mid-trained, and then the post-training and how you filter the data. So first of all, what is your take about data versus architecture? Like, what do you think is more important?
Yeah, I think that's like the key question in a lot of ways. Like, I don't want to sort of be negative about architecture because especially it is sort of, there's a lot of progress happening in that space right now, maybe more than in the last few years. So I think it's pretty
Some of
important, but at the same time,
some of my best friends are like talking about architecture, like knows friends with with a new model.
exactly, yeah. Yeah. And I think the data has been undervalued though. And it was true like, I don't know, a decade ago. I think it's still true today. And I think we could really invest a lot more resources in data. But I also think the world is kind of coming around to that. Like, especially now the data is more complex. So it's things like environments, simulations, rather than, here's a supervised learning data set. As a result, I think people actually do sort of see the value and are really investing there. And even for eval, right? So, I mean, if you go back 5 years, there were a handful of evaluation benchmarks that everybody used. Now there are like actually thousands, right? And people design new ones all the time. So clearly people have seen sort of the light here. They see the value. They're investing quite a bit. But we're not even close, I think, to where we really need to get. Like there are tons of spaces where we're very data starved. And I think for that reason, we should invest much more in data whenever we can without, ignoring architecture and all the improvements and innovations happening there.
Well, I'll point out traditionally when people ask data versus architecture, there's the third that they also ask: data versus architecture versus compute, and which is the most important out of those three. And it seems to me that I've always agreed that data was the most important, and then compute, and then architecture in that order. And indeed, it seems that right at the moment when data, like on the open internet, became far worse in quality because of the Ouroboros effect, everybody using LLMs now, so the internet's overran by it, and data protectionism. So companies that used to be very open and easy to access their data have kind of closed it off. It seems actually a pretty bad time in a way to be trying to get really large, high quality data sets. Do you think that, possibly as the quality of the internet continues to kind of go down and I would maybe call it lower entropy, do you think that this relationship still stands of data being the most important?
On your comments, extremely interesting. So I think, yeah, like you were mentioning basically scaling laws where you're talking about, should I invest in, compute versus the model size versus data and things like that. I mean, that's actually an extremely interesting question on its own, because I think scaling laws are not really like fully fleshed out yet. We have a lot of work to do there as well. And yeah, I know it's a controversial topic
It's a
because there are people who
scam.
don't believe in them. There you go.
Yeah,
Exactly. Yeah.
yeah, and we talked about it like in one episode. It's totally scam, in my opinion. But
I
yeah,
won't entertain
continue.
you with my thoughts on that. But no, I mean, I think it's pretty interesting. You're describing it as the Ouroboros effect, and I know lots of people are also very strong believers in that. And I think you see this with this general belief of synthetic data will definitely lead to model collapse. And there's many papers that really show an actual effect, but it turned out in very constrained situations, right? So I think there was a nice paper I saw a few years ago where they were generating data with a model, directly training on it, repeating that loop several times, and after 5 or 6 iterations or whatever, you would have model collapse, right? But all of this is sort of very restrictive, because in practice, I don't need to just train on my own outputs directly. I'll also train on some real data, some outputs from other models. There'll be more of this diversity and realism going on there. So it's actually not that clear to me that the synthetic takeover of the internet is really going to hurt us too much. And maybe I'm wrong about that. It'll be very interesting to see, if you really need way more pre-training data or way more filtering, for example, to really be able to go train a model. But I guess for me, I'm less interested overall in like pre-training data. There's lots of problems to solve there. But I'm not going to be the person who downloads, these massive snapshots and like starts playing with them, even though it's its own very interesting problem. I think I'm much more interested in like super high quality data that we use for post training. And there, I think it's actually almost the opposite situation. It's not that we have less and less good data available to us. In some ways, I think it's really motivated people to create much more high quality data. Now, I think you're right that there is sort of like an opposite tension. There's companies that used to release a lot of high quality stuff that are now like, okay, let's keep that for ourselves. Let's sell it. Let's do something, productive with it in some sense. But yeah, I think at the same time, like, I don't know, looking at how much really high quality math data people are putting out there now, just inspired by the fact that the models can really consume it and do something with it. I think that part has been really good. We really do just need more open source sort of high quality data efforts. And the other piece that I think is interesting here too is like, data's changing in a lot of ways. Like speaking of math, right? People write these papers where it's like, here is the result, here is the proof. You have no way of understanding how they developed that, right? You just see this final package. And even though this has actually been pretty useful for training models, and they are at the level of, I don't know, mathematicians in certain areas, seeing all that intermediate stuff is also pretty important, right? And this is just only now starting to happen, where people sort of annotate their data with a lot of like the intuition, the experiments, the stuff that goes into it. And I think that's really going to affect how we train models going forward. And it's a pretty exciting time for it. So that's why I want to see more investment kind of in this area.
And then it just a quick question on compute. It used to be back in the good old days of 5 or 6 years ago that people were training neural networks on hundreds of epochs over the same data. Right? The concept of epoch was important back then. It seems I have heard on good authority from people that many models, at least pre-trained checkpoints, never got a full epoch through training, that they'll exit it at like 0.8 or 0.9. What do you think? Like, future of like multi-epoch training is over now? Or
I
yeah.
think so. Yeah. Yeah. I mean, for large language models, probably, especially for these like, giant ones. If we're talking about, like small language models or tiny language models, it might be a little bit of a different story there. And specialized in multimodal models anyway, it's its own separate thing. But yeah, I mean, I think we can expect that we're just not going to go through the data set, and that's okay. I mean, if it's got enough redundancy in there, I don't think we're necessarily too concerned about it anyhow. To be honest, I think the dream, though, is to get a little more sort of sample efficient anyway, so that we don't have to worry about the trillions of tokens. How we do that exactly, I mean, we have lots of ideas for it, but I think it's still a largely open problem for scalably doing that. And that is going to save us a lot of compute, a lot of expense, things like that.
But why you think it's happened? Like, why you think like we moved from like, I don't know, training SSL on with 2,000 epochs to less than an epoch? What was the main? What is the main difference? Like, is the data? Is it the domain? Is it like the architecture?
I think it's all of the above, right? There's no like single piece. I mean, I think, yeah, with the kind of data that we have, it turned out that when people initially were doing pre-training just on Wikipedia, and this really dates back to like training word embeddings in like 2015, right? So like you would just download a snapshot of Wikipedia, train word embeddings there. And those worked okay, especially for these kinds of static word embeddings. But I think, pretty quickly people realized, especially as you scale up models, just training on Wikipedia, where really you could actually have a lot of epochs, it wasn't sufficient ultimately, right? So I think people realized, yeah, get more data, make it as big as possible, scale it up, right? That was sort of the general story that we had for many years. It made sense to keep going, even if you couldn't conclude even one run through the data set. Now, that might change today. There are other situations that we're going to have now. But I think, yeah, the sort of just general scaling story made sense for a while. Only now is it really breaking down.
So what are the properties of the data that you actually need? Like when now you look for good data, what you actually look for?
Yeah, I mean, that's the most fun question that we can have. I think basically what we find, especially at Snorkel, is, does this data really match up to the way that the actual model is really going to be used in practice? Which sounds simple, right? I mean, that's the obvious thing that you think of, but it's actually still pretty hard, I think, even for eval. There's tons of blind spots, right? Like you really cannot encode into any eval method, like everything that's going to get used for it. So I think what we try to do is to capture some very fundamental aspects of the way the model is going to get used. This is often very domain specific, right? So like very often our customers might be building some bot that's, helping their employees or interacting with their own customers. In that case, you want data that's sort of like rich enough to really kind of comfortably represent what it's going to get used for. So it might be, for example, that our data points are these multi-turn conversations, right? That require the model to do a bunch of tool calls or to stop and reason about things or to do RAG or other things, right? So like having that level of complexity in there and making sure that the model actually gets challenged by it and is not, facing some trivial situation, that's usually what we look for. At the same time, you also need all this stuff to make sense and be coherent. So there's a certain degree of quality and realism that comes of that as well. You can't just, prompt GPT 5.2 for give me a 10-turn conversation in this domain, let me go train on it or things like that.
And I'm curious. So I again, I work in sampling, so I like looking at entropy and perplexity quite a bit, at least from the perspective of maybe pre-training a large model. Would you think that data that is more surprising, higher perplexity or entropy, isn't that in a sense a value? You want to train on what surprises the model and probably not train on what doesn't surprise the model anymore because it already knows about it. Is that intuition broadly accurate in your opinion?
Yeah, pretty much. But the way you measure that surprise, that will change as you move from pre-training to sort of, up the stack all the way to some downstream skill that you're trying to measure, for example. But I think, yeah, that story is still there and it isn't really going to change anytime soon, at least as far as I can tell. I think it's pretty interesting because we do have, for supervised learning, we have a pretty good theory of that when it comes to things like active learning, right? Like I particularly want to sample data points that are close to my decision boundary, right? That is where the model might be most uncertain. So those points have the most value. And there, you actually have a fairly complete like theory of the kind of sample complexity gains you get from that. But I think, unfortunately, when you move over to like the LLM and generative AI world, this kind of stuff gets a lot harder, right? Like, how do I really measure what it means, to be surprised or what it means to be uncertain here? You have some trivial ways, but they don't always really kind of play out that way. But certainly that's what we're looking for all the time. What is the most high value data that we can show the model at any moment? But just to give you a sense of like why I think this is complex, right? Honestly, we don't even know any of the sort of equivalents from supervised learning in this new space of like RL and environments and simulators, right? Like I don't know what it means if I train my model, to be a good physician's assistant, whether any of that transfers over to being, I don't know, a banker's assistant or whatever, right? So like, what does it mean to be surprised in that case? I have no idea. What does it mean to transfer or to generalize? Even these things are like almost totally underspecified. So I think that's where we have a lot to do, basically.
Well, what do you think of things like the Platonic representation hypothesis, right? Because isn't there supposed to be that evidence, train on bad code, the model gets evil kind of stuff, right?
Yeah. Yeah, there's these very cool, like latent relationships out there. I guess I can buy it. How I can use that, right, when I'm actually going and building models, I think that's a lot more challenging in general, even though the overall idea, I think, is very exciting. I mean, the reason why I like those kinds of works is like, there's this sort of belief that large language models operate insanely differently, right, than like the way that humans would do anything, which makes a lot of things pretty hopeless, right? Because like in the end, human data won't do that much for us when it comes down to it. But the fact that you actually do get these types of things suggests that maybe it's not that different. Maybe there really is something more universal. So in that case, I think, yeah, we can be a little more comfortable about the future. But yeah, I don't have like an easy way to apply that kind of work and feel, very certain about it in general.
We have a recent, we just submitted to ICML, like a really cool paper that we can actually build a data set that you can decompose uncertainty. You can decompose like the aleatoric uncertainty versus the epistemic one. And we have one of the experiments. So we are using like normalized flow models because in normalized flow models, you have like tractable likelihood. Basically, for each sample, for each generative image, for example, the exact likelihood. It's not approximation. It's nothing. Like you have the exact likelihood, so you can decompose it. You can calculate the KL. You can do a lot of very cool things. And one of the experiments that we actually have done is active learning. Like we chose the samples themselves based on their epistemic uncertainty. And it gives us much better results. Like when which samples are actually useful, you can use them and your model will learn much more, like in a much more efficient way.
Yeah, we've actually done something a little bit similar. For us, the easiest way to do this kind of thing is basically to look at like difficulty, right? And people build sort of curriculums based on difficulty in general, even for training large language models. So you say, okay, well, I'm really bad at these points, treat those later. I'm a little bit better at these kinds of points, start from the beginning. One thing that we found is just like difficulty alone isn't really everything that you want here. Like sometimes you also have to look at other things. The other kind of interesting piece is like there's sort of different skills that help each other, and you really want to mix those in as well. So there's a whole art to designing these kinds of like data curricula. But yeah, I mean, the potential for getting big benefits, like can I train with 5 times less data? I mean, that's pretty exciting and worth us continuing to look into this. So yeah, I'm sold on sort of these, I don't know, modern forms of active learning for all of our current models as being a big research area. We should keep going with these. The only big question basically is, how do you convince someone to really scale up these techniques? I think, especially as an academic, also, these things can be pretty challenging. Like we can see benefits on a lot of different instances at small scale, but you have to sort of follow this chain upwards, convincing people that it's really valuable until, ideally you integrate it into all the frontier models and things like that. But I think that's actually a very big challenge as well. And like just having enough credibility to pull it off is pretty hard.
And isn't the notion of difficulty, like we as humans will find things difficult, but I claim that models, for example, I find it extremely easy to do even long, multiplication or division, relatively speaking. But models, due to tokenization, are structurally unable to do accurate arithmetic without tool calls. Similarly, the number of R's in Strawberry or any kind of character counting is effectively impossible in the general case with current tokenization methods, but almost trivial for a 6-year-old. So I'm wondering then, is our notion of difficulty, does that map, or can we get a mapping of that to LLMs?
Yeah, I think you're right. And I think that there are these sort of differences. You also see it with like positional embeddings, for example, that causes certain behaviors to be just very challenging for language models. So I think to me, the answer is, yeah, we can still sort of have a notion of a human to model difficulty map, but it has to be sort of modulo certain aspects of models here as well. Now, the one thing for me is, these problems do get solved in many ways by tool calls. So you should integrate that, right? Like, I don't really care too much about whether my model, using only tokens can solve certain problems. If it has to use tool calls and it can do those reliably, there is no reason not to permit that to happen, right? Other than, of course, convenience for experiments and things like that. But yeah, I think we should, as much as possible, not view LLMs in pure isolation, but rather as part of whatever, scenario or scaffold you're going to use. And only there should you really look at, like, okay, what does it mean to be a difficult problem and things like that.
I'll point out that there are still, and again, in creative writing, I don't think tool calls will help me force my model to output 100,000 tokens without the letter E in it correctly, right? Following character level constraints. I admit that this is something that only like weird creative writers care about, but I will, yeah, I do think there is at least a little bit of that kind of value for being able to do character level things, but yeah,
Yeah, I mean, I think that's where we
without
really get
tools.
into sort of the tokenization free method research. Sorry. I think
Yes,
we
absolutely.
Yeah.
Yeah.
So I'm wondering. So you mentioned before, like, what that you need credibility in order to take a small project, like small scale project, and scale it up. I'm wondering, like, what is your take? Like, how you do it? Like, because, right, like, you're both in the academic world and industry, and you need to apply these projects and make them work. What is your take? Like, how you take a method or observation, or like something that you get from really a small scale project, and how you use it, and what types of properties, or like, I don't know, evaluation or metrics you want to check in order to make sure that it will work in large scale.
Yeah, I think that's a great question. And I think it's also an art, and some people really have mastered this. And fortunately, I've been able to learn from a lot of people who have been able to do this quite a lot. I think that the main thing that I see is, right, like, there's some attitude of people who say, okay, I have this idea. Can I find, data sets or domains or scenarios where it works, right? And they're treating that as sort of like if there's a few things like that where it works, then great, right? The idea has some value or something like that. I think the thing you want to do is almost the opposite, right? You want to say, can I find any scenario where it doesn't work, right? Where it is supposed to, right? So I think that sort of approach to it is what leads you, right, to be really confident in the method. And then you can essentially expose it to the world. And this is something where I learned a lot from watching, like, Snorkel get built kind of originally as an open source project, and sort of weak supervision research more broadly, right? Like, it wasn't like, okay, we have a bunch of ideas, we'll write some papers, we'll see where it goes. It was much more like, first, we have this software artifact that everybody can use. We'll really invest heavily into it, make sure that it's extremely smooth and easy for people to use. And then we'll, allow anyone to use it. We'll even invest some of our own time and resources in helping them. So as a result, for like the Snorkel open source project, we used to have like office hours where we had 30 companies, like representatives, come and chat with us about how they deployed it internally, right? And then very quickly you'd learn, like, okay, here's the challenges, here's where it doesn't work, here's what works even better than what we thought, right? And like, all of that information really helped us. And it did give us a lot more credibility as we were building out this project. So I think that's sort of the approach that you have to take. Yeah, I mean, you have to be a little bit fearless, I think. Like, one thing that I struggle with sometimes with students is like, they're kind of afraid of trying their idea on every possible case, because often, like, they're a little bit in love with the idea, right? And like, knowing, well, it might break, right, if I try it in this setting or whatever. It's a little uncomfortable. And I think, yeah, that's one thing I always get my students to do. It's just like, hey, an idea, it's not your friend. You really want to attack it as much as possible, right? Rather than like keeping it there and sort of like defending it from any possible counterexamples.
And I'm glad you brought up weak supervision. First of all, I'm hoping people on the call kind of know what that is, but I'd love for you to define it again. And then second of all, I'm very, I feel like the field has especially gotten away from like unsupervised learning, and maybe to a lesser extent, active learning, which you also talked about, and maybe you should also define. I think maybe you did, but I feel like active learning has also become a bit less popular, maybe not as much, but at least for a time it was talked about less. So I'm curious, especially first of all, like for your definition of those words, but also, do you think unsupervised learning has a role to play with LLMs still? Because I personally find it by far the most pure form of learning, and I really do wish that I could work more in it, and like clustering and dimensionality reduction, because most data I claim in the world has no labels, right?
Ju- Just
Yeah,
just one
go
more
for it.
follow up, like just one more follow up question, like every time, like we are asking it, so what is your take on like world models and Jeppa style models and all these things that Ellen mentioned also?
Yeah, great questions. So I think weak supervision is interesting because it's this overloaded term. But like very roughly, you have this sort of classical supervised learning world. I get all my data and it's all labeled. And, ideally those labels are ground truth. They're clean labels. There's no noise or things like that. And I mean, very quickly people realized, that's not that realistic because we can't scale up our data sets to all have that. So they started looking at all these alternatives. Like a popular one for a while was semi-supervised learning. So I have like a subset of my data which has labels, they're clean and so forth, but all the remainder is totally unlabeled. Then I think there's sort of all these sort of variants of this, and many of them get labeled with weak supervision, which could mean lots of different things. The type of weak supervision that I study and that kind of Snorkel was originally building, a lot of that was kind of saying, hey, I don't have any clean labels, but I have all of these sources that might guess what that label is. And the big challenge is that all these sources are noisy. So you can't just take their guesses and say, I'm sticking with that as the label. You kind of have to figure out how noisy they are and ideally aggregate what they guessed into something that's a little bit more high quality. So this has a lot of these theoretical, algorithmic, kind of practical aspects to it. But the sort of ideal way of doing it is, okay, well, I ask, an expert who normally would have to manually label a data set, like, can you tell me the intuition, the heuristic, the logical rule for why, you're labeling data the way you are? And if you can translate that into something cheap and easy to apply, like some programs or some code, for example, right, then you can label data as scale. The downside, of course, is that you're not as high quality or as expressive, but if you can sort of deal with that by having multiple sources and kind of independent views of these things, then maybe you can kind of exceed that. So I think this is kind of what we mean by weak supervision, but there's lots of other versions. Sometimes it's things like, oh, I can get these additional features for some of my data points, right? Can that help me, for example? Or, I don't get a full label, but I can tell you, for example, that the correct label is in this subset of labels over here, right? So there's all these different meanings that people have, but it's any scenario where you're not in kind of classical full supervision mode. And I think these things were incredibly important, and they actually still kind of matter quite a lot because you can use these, for example, to do, supervised fine tuning. You can use these, for example, to do like very efficient preference labeling. So they still have a ton of value, even kind of in the LLM and generative AI space, but they used to be almost everything when we were doing a lot of supervised learning as kind of the main thing. And active learning, of course, is similar in the sense that rather than passively collect a data set and train on it, we'll sort of actively choose what data points we're showing to the model during training. So this is one of the kind of classical definitions of active learning. And I think honestly, like all these things have not really gone away. It's just like you view them as part of this larger stack that you have to have, right? Because pre-training itself is, it's officially supervised, right? But it's this more weird, intermediate,
Self-supervised,
semi-supervised
right?
kind of thing anyway. So yeah. Yeah, and self-supervised is a tricky term anyway. What does that really mean? How is it different from supervised? But anyway, yeah, I won't get into those debates too much either. Yeah, for world models, I don't know. I don't know exactly what one is yet. I think like actually defining it very coherently still seems pretty hard to me. Like intuitively, I can believe in the story. Is this sort of the main object that we should focus on? I think for some applications, probably. For others, yeah, I'm not so sure about that.
It was like an elegant way to say that, like, like world models is not important right now, right?
Glad people are excited, and the energy is great. I'd like to see where it comes. Yeah.
There was that new Genie release from Google that now a lot of the general public is starting to see what we're calling world models today, video models with control.
Yeah, it honestly is pretty impressive, and I've seen people get excited over it who've had access. So yeah, there clearly is some awesome stuff going on.
For sure, there are so many startups now about world models, right? At raising tons of monies. Okay. I think we almost finished. Is there anything else that you want to add, to advertise, to say to the audience?
Yeah, I'll mention one thing that I've been thinking of, and also my group as well, which I think is pretty interesting. And I think it's this question of basically what happens when, the human data that we build, right, maybe isn't really at the frontier anymore. Like I think for a long time, the idea was, models are sufficiently weak that you really just want to get them to be good at, on human data, and there's nothing else to it. And that wouldn't be expert human data. It would just be stuff that anybody could do more or less, right? Like ImageNet, you don't really need training to be able to manually label the images, right? So as long as we get models that are good at that, that's still pretty good. I think now it's much more like, okay, I want my, LLM to be as good as a regular professional mathematician. And, ideally, I'd like to get it to be at Terry Tao's level, however long that takes, if ever, or whatever. But supposing we do reach that point where LLMs become, at the frontier themselves, or maybe even a little bit beyond it, then like sort of what's the next training phase? And I think that part's actually something very interesting to think about. How do we start generating data for that scenario? A lot of the data naturally will have to come from the models themselves if humans aren't really up to it. But like, how do we do that kind of control? And that's something that I think is very interesting. It does relate to this thing we were talking about, this weak to strong generalization, right? That's where you have this weak teacher, and in this case, it could be humans, for example. They really create the data that these much more powerful models are trained on, but you still want that data to sort of help that model generalize beyond the weak human. So I mean, that's a fun thing that we want to think about, especially for those of us doing kind of data side work. How do you create special data, right, that like a model that's smarter than a human can still benefit from down the line?
And this is
And
very,
also how
very
you,
sorry.
yeah, and also how you evaluate it, right?
Exactly.
This is
Yeah.
also like one of the main questions. Okay, yeah, very interesting question. Anything else that you want to add, Alan?
Well, I'd honestly forgotten Snorkel existed. And not, I don't mean that in a bad way. Just, before generative AI, weak supervision, I feel like was starting to take off, and I almost consider it a casualty of, in much as how a lot of the, scikit-learn and a whole lot of things that I think would have gotten more development in a world without LLMs. I almost think that we over-indexed too much on LLM everything and forgot about, core fundamentals. So I really am happy that I could sit down and chat with somebody from, a firm that understands that we still need these fundamental things like weak supervision to take the best generative models and make them better.
Exactly. Yeah. I mean, I think it's not like these two things are in tension or in conflict of each other. I think they're actually like really cooperative, which has been great. And especially the last couple of years, the Snorkel has become sort of a major data vendor and creates like all kinds of custom data. Seeing all the principles from weak supervision also filter into that has been a lot of fun. And I'm convinced it's also the right way to keep going for the future too.
Okay. I think we are out of time. So, Brent, thank you so much for joining us.
Thanks for having me. It's been a ton of fun.
And thank you, Alan.
Always a pleasure.
See you next time.